Hello, so in this video we're going to take a look at attacking some hashes. So it's possible that in a competition environment, either as part of a capture the flag type event, or maybe if you actually have an offensive type scenario, where you might get a hold of a hash and maybe the event or the challenge is that you're designed to try to crack the hash and guess what the password is. And we're going to see how to do this, and we'll do this off of a Kali Linux machine here. Now there's a lot of different tools that are designed for hash cracking. I'm just going to use one here that's it's a little bit sophisticated, but it's very powerful if you can learn how to use it. So one that I've used before is Hashcat. Okay, so I'm just going to type out Hashcat and see the general options here, but there definitely are other password cracking tools that you can research on the internet. I'm definitely not going to show all of them here. So you got to kind of figure out what's the format and what can you do with it. But let's see a contained example here where this one might be an appropriate tool to use. So you kind of see here under the usage when I just type out Hashcat, you have to type out Hashcat, you give it some options, you're then going to give it the hash that you actually want to try to crack, and then you want to pass in a dictionary. So this is something that requires a list of passwords to be able to try to create the hashes and guess and be able to crack the password. So how do we do this? And this is the different pieces that we're going to need in order to actually build this out. It also says you could type -- help for more options. So let's see what that looks like. If I go Hashcat -- help, and of all the things that we've done so far, this probably has the longest help section of any of these commands that we've run. So, and the idea here is that Hashcat has a lot of potential options. It has a lot of different hashing modes that it knows about, and it lists all of them here. So when you start reading through the help, you get overwhelmed really quickly as to just, I don't know which option I need. There's so many that I have to choose from here. I'm going to walk you through kind of a simple example because learning Hashcat has it's got a little bit of a learning curve if you're not quite sure where to look. Okay, but remember, we kind of need these three pieces. I need to have my options, I need to have a hash that I'm going to attack, and then I'm going to need to have a word list as well. So let's work it all the way backwards. We'll start with the word list. So if you're working on Kali, you already have a word list built in. And it comes with a word list that's got 14 million passwords built into it. Most people just don't know about it. They didn't know it's built into the file system. So let's go take a look at it. And it's in a folder. I'm going to ls over to the folder, or I'll cd over to the folder. It's in /user/usr/share/wordless. And this is where we have a couple different word lists that are built in. And when you do an ls out of this location, you'll see there's this rocku.txt.gz. So rocku.txt is a word list, like I said, with 14 million passwords. They were actual unique passwords that have been kind of built into Kali. And right now it's zipped up. So it's .gz. It's actually, this text file has been zipped up. So we need to unzip the file so then it can be used. So we're going to unzip it through a gunzip command on rocku.txt.gz. And we just go ahead and hit enter. It takes a couple seconds to run to actually go and unzip it, but now when you do an ls after the command is run, it should no longer say rocku.txt.gz. It should just now say rocku.txt. And if you were to cat this guy out, or if you were to open it in a text editor, it might take a little while because it needs to load up 14 million lines worth of words. Every single line has a different word on it, a different password. So that's what this is really good for if you want to have a very thorough dictionary type attack. This is one that we can use, and it's built right into Kali. So that's kind of our dictionary. We'll use the dictionary there. Next will be, I'm going to just cd back to home. We can run this out of the home directory. Next will be to see what's the hash that I'll use. Now, if you remember in previous examples, we took a look at the shadow file. So the shadow file was the thing that had the hash for the different accounts on this computer. So let's see if we could just attack our own account. We'll attack our own root computer account. And I'll do this by going to catting out. I'm just going to cat out the /etc/shadow. Okay, and this, remember, will spit out all of the different users and ones that actually have information after them, such as root. This will be the one that actually has a password. Okay, so why don't we use this? And you'll see there's a whole bunch of other different accounts on here that we don't actually need. So why don't we get some practice using commands like we did before? We'll grab that hash just for the root user and kind of get it ready to actually go and be attacked by Hashcat. So we could do this by doing a cat of /etc/shadow. But this time we're going to pipe it into grep, and we're only going to look for the line that says root. And let's pass this into a new file. We'll make a new file here right in our home directory called hash. Okay, so I'll run this command, and now when I do an ls, you see I got a new file called hash, and when I cat out hash, I've got kind of a simplified version of the shadow file that only had the root. Okay. Now let's go and let's modify this file. So I'm going to modify this file with, let's just say, nano or vi, whichever you want to use. I'm going to nano hash. Okay. And in order to use hashcat, you need to have the information in a very specific order. So I don't need this root. Hashcat does not want the username, and it doesn't want the colon either. However, this $6, that's very important. That indicates the type of hashing that we're going to use, and we're going to see how that's going to be important in a second. The next $sign here is the salt. Remember, this is information that's added in addition to your password. Modern password systems will take a salt and add it onto your password and then hash it. Okay, so we're going to need the salt, so then the hashcat can reproduce my password plus this unique salt. And your salt is very likely going to be different than mine. Even if we have the same passwords, we're all going to have different salts. That's okay. And then the rest of this big long thing here, this is all the password, all the way to the next colon. Okay, so everything from this colon to the end, I've got colon 17605. This we can all delete out. Okay, so go find the next colon there at the end of the file and delete that out. So mine happens to end with lczs/. Okay, that's just what it happens to be. Yours is probably different. But I'm going to hit Control X, Y, and Enter to actually save this. So now when I cat out the hash again, it starts $6. It's going to have a small little salt in between another $sign. Okay, and then it's going to have the whole big long hash. Okay, so that's the format that I need this particular hash file in. So that's the second piece that I need in order to run hashcat. The last piece that I need is to know what are the options of hashcat that I want to run. And I'm going to do this by looking for the type of salt to be able to identify the type of hashing that I actually have here. And you can do this by doing a hashcat --help. But remember, this is going to spit out a big long list of a whole bunch of stuff. And what I need to find is when it's $6, that indicates the type of hashing. So I need to figure out what type of hashing actually is that. And I don't want to go looking for it up and down on that big long list of help. You could use something like Google, or we could learn some of our commands here, and let's do a grep for it. So I'll grep. But anytime you're going to grep for anything with $signs, it might think you're going to try to run a command. It's going to run a script. So we need to do just a $F to force this to be a string. I want to look for the string, put it in quotes, a single quote of $6. That's what I'm looking for, and then end the quote. Okay, and so when I spit this out, it should spit out just one line. There's only one line. It found the one line that we're interested in here. It says 1800, and then it's SHA-512 crypt. And that's the $6 SHA-512 in Unix. So this tells me on a Unix system, which is what Kali's built off of, we're using SHA-512 as our hashing algorithm, okay, which means you want to know that the key code to actually identify all that to hashcat is this first number, 1800. Okay, so I'm going to do hashcat now. I now know enough for my options. I'm going to do a -A, which indicates the attack mode of straight through. Okay, I'm just going to do a 0, which is the basic attack, which says go through everything in my dictionary file. Some of the more advanced attacks will say do everything in the dictionary file and do options, do permutations and combinations of things in the dictionary file. I'm just going to go straight through the dictionary file with a -A 0. -M is the attack mode. That's where you would specify the hash, and that's the number we just found, this 1800. So I'm going to do -M of 1800. Now I need to say where is the file that has my hash, and remember we just called it hash. And lastly, I need to say where's my dictionary, and that was in /users/share/wordless, and we're going to use this rocku.txt. And now on an ideal system, on a perfect system, this would actually go and run through and crack the hash. Sometimes you need some additional options though. I'm going to have one additional option that is, I'm going to disable the POP file. You don't have to do this, but realize that what hashcat will do is as it runs through and actually cracks hashes, it sort of saves them to what's called a POP file. So then the next time it sees the same exact hash, it says, I don't need to crack this anymore. I'm not going to go through all the steps. I'm just going to say, hey, I know the answer already. And just for this example, I don't want to do that. I want it to actually go through and do the cracking and do the computation every single time, just for example's sake. But if I was doing this in practice, I would want to keep all of these in a POP file. But I'm going to go --POP file -disable. I don't want to use the POP file. And then I'm going to go ahead and hit enter. and we'll see if this runs. All right, so it ended up not finding the device. So a lot of times Hashcat can say, maybe you want to use your processor, maybe you want to use a video card to do the processing because it could be really process intense. So if you do get a device error, you can say, you can use -- force to override this. Okay, and I'm going to say, okay, sure, that's fine. I'm not worried about this. I'm running on a virtual machine. I'm going to go -- force. I'm not going to try to use my GPU or anything like that to go and crack lots of hashes because this is just a small little example. So I'll say -- force. It goes and it finds my card, builds that 14 million password list, and then gets to the end. Okay, and this one actually ran in pretty much in 2 seconds, okay? So let's take a look at the output. You see the Hashcat is what ran. The status is I cracked the password. Here's the hash using the algorithm that I actually found. Here's my word list. It only ran for 2 seconds, and when you look above, here's where you actually see the output. Okay, so here's my actual hash all the way to here, and then you notice it goes : password. And the password for my root account right now is the word password. So that's what ended up happening. If this did not find the password right away, because I've got such a simple password, it would just be guessing. It would start guessing through that list of 14 million passwords. And on a 14 million password list, especially with a virtual machine, I could expect that that might take maybe 2 to 3 hours in order to calculate and guess all of the hashes that are actually in that list. So it's not going to guess it right away. It needs to do lots and lots of calculations. But this is the type of thing you just sort of let it run, and maybe it gets lucky, maybe it finds the hash if it's a password that's on that list of one of those 14 million. The only issue there is how fast is your processor? Do you have a GPU to kind of speed things up? That's something that can improve the process of all this. But otherwise, this is kind of the intro to cracking hashes, and maybe in some of your capture the flag type events, if I ever get someone's shadow file, or if I get something that looks like this, it starts with some $ to indicate the type of hashing. Okay, this should give us a halfway decent process for identifying and cracking a hash using Linux, using Hashcat.